So welcome everyone. Welcome to the system design basics session. So I will give you a brief overview how it started on one of the channel. A couple of uh, inexperienced folks, they were discussing that, hey, let's do some system design discussion or solve some problem. And I asked them, why don't you go and record it, and we'll see what you are lacking and other things. But they didn't record it, and they said it was total mess. So I had two questions in my mind, like for a very new folk, like fresh out of college. Personally, I didn't used to expect a lot of design skills, but I'm pretty sure maybe things have changed. Now people are expecting, maybe companies are expecting, but anyway, I wanted to help them. So I thought, okay, we'll do some session. So I used to do a different kind of session. So far I was doing some coding problems and other stuff. But then since this is Sunday is like optional, we can do anything. So I thought, okay, let's do this. So that's the reason we are doing this. So my primary focus was for people who have less experience. But looking at the crowd and excitement, looks like we have some experienced folks, and there are a lot of folks who have some experience for sure. So we will see how it goes. We'll start with the basics, and then we'll move as we make progress. So from my point of view, what I am going to do, it's a huge topic. If you start just looking at one thing, if you start to go in in depth of this, it will take forever actually. So we can't finish things. So we'll just touch a lot of bits and pieces, the different components of the system. We'll touch those so that definitely at least freshers, they will get some ideas. A little experienced guys, maybe they may know it already, but they will know why we are doing this. And then you can go and read some things if you are actually going to use it. And for the experienced folks, I ask, please chime in to answer the questions if people have. That's my expectation. Also for the Sunday session, I think yesterday there was a session, and it was Bhavesh who told there has been some system design session already. I didn't get a chance to look into it, but please go ahead. There are some videos on our channel. So go and take a look after this session. That will help you also. So with that, I want to start the session. And if anyone has any questions, feel free to jump anytime. Okay. So I will share my screen. Okay, you guys can see my screen, right?
Yes.
Okay. So we'll start with a very basic thing. Like suppose you are building some software to start with, and you can choose any language, say Java, C Sharp, or C++, whatever. And you have built a service here, for example, and you want to sell it. People are interested to use your service. So one approach is you build the exe or jar file, and you give it to the clients. They or maybe they download it from your website or something, right? So different clients can download your software, let's call it C1, C2, and like that. And they get your functionality. It doesn't matter which kind of service is this. It could be a very simple service. It could be a complex service. So in this particular case, what is going on? Like, how would you distribute the service? Like how people will buy your service, for example?
You can host your service somewhere and, make a doc of the API and people can access that API.
Yeah, but how will they, they have to install it locally on their desktop, right?
So we can deploy it in like cloud or like that, so that people can use it.
Okay, so we'll talk about that. So yes, so the problem with this approach is, like, suppose there was a bug. If I fixed a bug in one of the version, for example, for client 2 reported some bug, I updated it, other people will not get it unless they try to download a new version, right? For example, like, Microsoft Word, for example, some version of it, any like, client based software, right? So you, so the distribution becomes tough. People are not able to use it because now if I have to get like, I'm using Mac, I'm using some other OS, then uh, you have to have a different version of your like software also, right? Same thing will not work. What used to work on Windows, maybe it will not work on Mac, things like that, right? So I mean, how would you go about? So somebody was proposing like, put it in cloud. So essentially what we are going to move towards is that instead of hosting this service as a jar or something, can you deploy it as a like, web application to start with, like, let's call it web application. It's not necessarily a web application, but what we are like, coming to, suppose my service is here. I call it my service is accessible at a particular URL. And here are the clients. Still I have C1, C2, C3, and they can make a request. They can get the response, right? New clients, they can immediately like, they can continue to join here without, without much problem, right? So this model is called client server model. Is that right?
Right.
Okay. So I believe like most of the people who are even like, very new to this like session or system design, they will probably know this thing. So there are clients and there is server, and then the, like, client makes a request using a web app, like say browser or mobile, that kind of like, way, and they will get the like, there's request and response on that HTTP, like, using this protocol. It is easily available. Now, one thing, while I'm going through this, I would try to introduce a couple of terms also, which will help maybe in future when you look at it. Suppose you are going to google.com from your like company, you are like, browsing that. So what happens, there could be, this could be your company's like network, like, or maybe from my home when I am doing this, I need to go through my ISP providers. Like, my ISP provider will forward the request to the server, and it will get the response from the server, and it will come to me. This is how it goes. Okay, there is no question, I hope, but if there is a question, please let me know. You can speak also. So what I'm trying,
I'm actually following on the chat as well. So in case there is any chat or anything, I will interrupt Roger. You go ahead
okay,
and focus on the session.
okay, great. So what I'm trying to introduce you about here, it's called forward proxy. You will hear about that. Forward proxy, what it does, so this server has no idea who the client is, basically. So there is a person sitting in between, think like that, who is proxying for all these clients. So to server, it appears the same. And here, like, what benefit we can do if we have this kind of proxy. Suppose I want to block some URLs. If I want to do some like, add some rules here, I can do that here in forward proxy. So I just wanted to give you an idea, like while we were discussing that. So this is how it works. Now we'll move to the more important thing. So forward proxy, now let's call it, actually I have to change my diagram a little bit. So wait a minute. Yep. So now my question will be, I hope this was clear.
There's a question on what kind of rules can we set?
So like, you can have all these kind of rules, like which kind of URL you want to block, for example, all like a firewall kind of rule you can set there. Then you can allow, disallow a certain client to make like, you can, if possible, you have to like, be smarter about it. You can throttle clients also, like, but then your forward proxy should be smart enough to do that, because it knows which the IP of each clients, right?
Okay,
Is-
understood.
yeah, is it the firewall? Yes, it can act as the firewall. You can add header if you want. You can do that. So it's a very generic concept. Let's don't go too much in like, in depth of that, but yeah, please explore it. Okay, so now your application is still like that. Your clients are here. You built a service. It is hosted in web, right? And suppose this used to work like, in a very good way. Now our service, like we have too many clients. It has become really famous. So how would you handle more clients? Suppose this guy is not able to handle clients. Like, after 50 clients, for example, it can't return response. It is like, overloaded. Any idea? Anyone?
So you can either add more servers, so that's horizontally scaled, or you can increase the performance of the single server. That would be like vertically scaling it.
Yeah, who was that? It's a good answer.
Hi, me, Ruchika.
Oh, thank you. So what Ruchika just said, maybe like, we can vertically scale this. So suppose if I was using some like machine, medium level machine, I will buy a hardware which is like, better hardware, and we can scale vertically. That's what is called vertical scaling. So that is one approach. Buy hardware, replace it. It will have some downtime because now you are like, going to deploy into this new server. So you may have some downtime, but it will work up to certain extent, right? Because there will be a limit for the hardware, right? CPU, RAM, all the memory, everything has a limit. So that will not work. So what now Ruchika suggested, another option is horizontal scaling. So what we do in horizontal scaling? Now we add,
We had more machines.
so now we have more machines, for example, like this, we have more machines. So now I have this problem. Okay, I have more machine. Now my client, I have suppose 1,000 clients, for example, and suppose I am able to handle this load somehow with 3 machines. But how would the clients will be routed? Like which request will go to which server and who will do that?
I
You
guess
can add a load balancer in front of the multiple servers, and then individual ISPs can connect, and the load balancer will decide according to loads on the server which request fulfilled by which server.
Okay, so this was Ronak, right?
Yeah.
Yeah, thanks for the idea. So what Ronak is saying that, okay, now these clients can go to like, there are 3 servers, for example, in this particular case, and somebody has to route the traffic. So it's like, there are 3 engineers, like, they are very busy, and who will know like who is busy or not, like, so there should be a manager which will come and he knows exactly who is busy, who is not. Accordingly, he will sit here. Let's call this guy, for now I will not call it anything, but it's a load balancer. He knows about all these guys. So request comes here, it gets routed to the different servers. For client, why it is good that the client doesn't need to know about the individual servers. Like, he doesn't care like where the request goes. For him, as like, like if the request response is successful, that's what it cares. So let's call it load balancer for now. We will talk about it a little bit more. Now my question is here that we have now.
Before you move on, right? We had a few quick questions. One
Yeah.
is, won't this become like a single point of failure as all requests are passing through it?
Yes, we will talk about it very shortly. Yeah.
And then there was also some comment about sharding in top of vertical and horizontal. So I'm sure you can cover that later.
Yes.
I think.
And can the load balancer also share the request, send the request based on the type of request? Was a question. Can the load balancer decide where to send based on type of request?
Yes, that's a very good question. So let's cover everything. Please, bug me if I forget about it. But let's go in this like scenario. We'll talk about it. So problem, before even we go there, is now, these are normal servers, normal machines, and you know that machines fail all the time, right? So suppose some machine failed. How will load balancer know about it? Like, will it continue to send the request to that, or how it will start the routing? That is my question.
It will load balancer can keep a track of the health of each server, and if one goes down, so it will not route requests to that server.
Okay, so this was Pop, right?
Yeah, I'm so sorry to say my name.
Yeah, it's okay. Whatever is your name. I'm also not Roger, but I am called as, so it's fine. So anyway, so what CJ suggested is that health check. So all these servers need to somehow tell the load balancer, or the manager needs to know about it's like, it's engineers, like he's healthy or not, that kind of scenario. So that is where you will have this health check URL. So you should have something like which this load balancer can always continue to ping to get the status. It is also called, you can say, heartbeat. That, hey, are you like, available or not? If not, then that server is out of the like, rotation, like, it will not send the request to this guy anymore. Now it is possible that there was a network failure, so still load balancer will just remove it, and then it may check occasionally to see whether this guy is again ready. Then it can start sending sending you the request. So that's why if you have used any cloud, any load balancer, you will see that they may ask you to provide a ping URL or health check URL. It is probably also, it could be called LB probe, but yeah, I don't know, but they're similar in
It's
concept.
called, I guess, liveness probe or readiness probe. There are two concepts, I guess.
Yeah. So is the voice clear?
It's clear for us. Arpin sir, I think there's a problem with Zoom at times, so you may want to disconnect your audio and come back. It might actually work better.
Okay. So yeah, we covered that part. And now we can also talk about a little bit about different kind of load balancers. So somebody had this idea, can we forward the request based on certain type of request, right? So there are a couple of different kind of load balancers. So let's call it L4, L7, it's common. In my opinion, please correct me if I am wrong, because I haven't went through this in detail, that L4 load balancer, which is basically 4 means the IP level load balancer. It is not used that much anymore. It used to be used a lot earlier when our systems were not that efficient. So what it used to do, a client made a request, it went to the load balancer, and then you have suppose these servers. So it will look at the source and destination IP, and the destination IP is for this load balancer only. It will translate this request with a different destination IP. It will get the response. It will change the again source and destination IP to make sure that for client it always knows that load balancer replied to it. So what happens? The load balancer will never look at the content of the packet at all. So it's very secure. It used to be fast. There was no overhead. So that is where this load, like a level 4 load balancer is used. Maybe it's still used, but most of the time, like all these cloud providers, what they do, or you use some open source, Nginx and other load balancers, they may offer this too, maybe, but mostly you will see this one. This is called
So hey, Roger, can I just take a stab at few other things? So one, if you folks haven't looked at it, you should definitely look at the Osi model. There is like a 7-layer model for it, where the layer 1 is like physical layer, the layer 2 is data link layer 3 is network. If you just Google it, you'll find it. The level 4 or layer 4 is essentially called the transport layer, and that is where your IP address and whatnot comes in. Then session is level 5, presentation is level 6, and level 7 is application. So the L7 load balancer is actually aware of applications. So the way to think of this is, imagine you have like a receptionist at the office, and he or she is picking up the call that comes in. Now that person can actually ask which department do you want or what, and then route the call intelligently and smartly to the right department. Or they can just randomly route it based on just the phone number that's coming in. Like they can read the number that's coming in and say, oh, phone number 1234 actually spoke to John, so let me just connect him to John again, or things like that. So you could do something very plain and naive, and that is actually a very quick way of doing it. And the load balancer does not require a lot of intelligence at an L4 level, and it doesn't need a lot of configuration. L7 needs a little bit more. It does it looks at the content, understands what is in the content, like, oh, you actually are looking for the billing department, so let me connect you to somebody in the billing department. And are you looking for this? And in the billing department, you already spoke to this person before, so let me connect you to that one. That kind of a equivalent system, if you build it in a software model, then that's sort of the L4 and L7 load balancers. I hope that is this is more like a simple analogy to this concept.
Yeah, thanks. That was very useful. Yeah, please go ahead and look at this OSI model. If you need more details, it will be more clear. So let me erase this because I need a space also to talk about newer things. So what we are going to do, we are going with most likely say like layer 7 on load balancer, like most of the time. And what we can do, we can look at the header. We can based on the header, we can make different rules. You can intercept the request. You can filter the request. You can do you can add all sort of intelligence there. So suppose if the request is from for a particular API, you can totally route it to a particular load balance, particular server, or maybe even a load balancer, because maybe you have a lot of services which is again hidden behind another load balancer. You can do that kind of routing. So that brings me to another thing, which is called reverse proxy. You remember we just talked about forward proxy. So in that case, like server didn't know about the client. In this particular case, what happens? Client does not know about server. So let's call this as a reverse proxy. So what you can say like, hey, S0 doesn't know who the client one is. S1 doesn't know who the client two is, like if it was routed the request there. So you can add all these kind of intelligence on top of it. So this guy now not only acts as a load balancer, but it does a lot of other things like filtering the stuff. Maybe it will not even send a request to the any server if it thinks that, hey, this is a blacklisted IP address. There was a DDoS or something going on. Somehow it figured out. You can have a lot of intelligence here. So this could be your load balancer plus other things. So it's a basically, in my opinion, it's a superset of load balancer. If anyone has more ideas, feel free to chime in. Okay, if not, then what was the question? Did we miss any questions, or I can explain other concept?
We can move on. I think there are no questions.
Okay. Now another thing, let's talk about briefly about CDN. I know there are a lot of things, but it's a good time to talk about this now. So suppose you have your service, it's a very popular, it's in all the countries, and you have your server in US, for example. So think about people in Australia. Your server is here. People in Australia, they are making requests from here. People in India, maybe they are making requests from here. People in US, it's here, things like that. You have a data center, for example. Let's assume that too. So there are two kind of contents you normally have. One is static content, and one could be your service, like the actual logic, like server side logic. So what is happening, like people who are very far geographically, they still have to go through all these network hops, and then they have to download it. So they see not a very good response time. So can someone tell me what CDN means? Well, I'm pretty sure you guys know. So once you will explain, I will actually try to explain a little bit more.
It's a content delivery network which will store the static content. So whenever we get a request for static content, instead of serving from the server, it will directly serve from the CDN. So request won't even come to the server.
Okay. So what we just talked about. So content delivery network, and there are a lot of content delivery network. I have used Akamai in past a little bit. Then I think all the cloud services, they have their own content delivery network. Bigger companies have their own personal content delivery network. What the idea is, geographically distribute, at different places, have your servers which can store static files. Like it could be JavaScript files, it could be images, it could be videos, that kind of stuff. Your page is built of a lot of stuff, right? So it would be great if these things get loaded as soon as possible. So that is the basic promise of CDN, that okay, if you put it there, you don't even get a request here for a lot of calls. So suppose it's, first of all, it's already helping you to scale your service, right? Because now your service is getting less number of calls. It is being handled by this cached thing, which is geographically distributed. And this is very fast also. So people have good experience. Okay. So now the question is, there are a lot of, there are a lot of things going on. Sorry, I can't follow, but let's talk about this for now. Question is, how uh, how it will be determined which CDN server a request will be sent to. So
Can you actually answer the question of how is CDN different from a cache?
How a CDN is different from a cache? Okay, yeah, sure. So we will talk about cache later, but cache can cache lot of stuff, right? You can have like, you want to save your database call and things are not changing. Or if you are willing to like spend, okay, like, hey, it's okay if I have a stale data for 5 minutes or 30 seconds, you can get the data from a cache, right? You can put it there. But idea of CDN is like, even if I may have it in my web server, for example, then I have to build this network, which is geographically like, situated in all the regions, right? So it could be in all the countries, like it's a huge network. I will not be able to provide that kind of response, right? Unless I start to like, have actually start replicating this CDN myself. Does that make sense?
Can you repeat it again? I didn't get it.
Okay, so let's take a look. This is the world. I may have server at 4 places, like 4 like, countries. But what these guys have done, they have put like, everywhere they have their CDN servers. All these points are like, CDN servers. So these companies only like, they are building this infrastructure. So now if the guy is coming from here, even if I have a like, place here, this guy will go to here through the network hops, lot of network hop, and then I will serve him the traffic, like, the response. But if it was already here, for example, all these points, what I am doing, I am distributing my all the static things everywhere, like, at all the points. So for any place, it will be closer than my normal servers. I will have deployment in say like 4 countries, 8 countries. Or if I am trying to deploy everywhere, so basically I can say I have built my own CDN server. That's also other way to look at it. Is that clear?
Yeah, clear.
Okay.
Who updates this CDN like this? Like we regularly update the CDN, like.
Yeah.
Okay.
So I just wanted to static file itself. So you generally don't regularly update it. So you update the resource and you get a particular URL or something and you use it in your service.
Okay.
Yeah. So it's like a cache in this particular case. Like suppose something was not there, right, in one of the server. So if there was a cache miss, basically it will still look at our server. While going back, it will say, hey, actually this thing is useful, so let me cache for the next client. So now it is here. Now think about your server. Now, if any client in that region makes the request for the same thing, at least that request doesn't even reach your server. So this guy is basically able to deliver the response, like, on your behalf. That's why it used a lot.
I have a question. How can there be a cache miss if for whatever resource we load into the CDN, we get a URL for it? So how could there be a miss?
So it is possible. It depends on how you implement it. So for example, one way is that in your URL, you already have put that resource is at this particular like endpoint, right? Like JavaScript is at this particular URL endpoint. So most likely in that case, it may not be the case. However, suppose there was a request for your, like, which ideally needs to go to your server. Somehow this guy intercepted it. And that was my next question, which I wanted to come anyway. Like, how will that happen? Then this will see, hey, it's not here with me. Let me check to the origin server. So that's why these guys are called edge. And these guys, which is our server, it is called origin server. Ideally, origin has everything, or it may have like, most of the things. So now edge server can ask origin, hey, I have no idea about this. Do you have this? It can say, okay, yeah, let me check. And it will send it to him and he will cache it. That is one way to implement it. Does that make sense?
Okay.
Yeah. So let's come to this thing. Another thing was DNS cache actually. So DNS cache, what will happen? Like, okay, there are so many like CDN URLs, like, hundreds of CDN where the request can come from. So when you call google.com from different countries, do you think that Google's request goes to the same server? It doesn't go to the same server, right? Every time you make a request, you can look at it on the network path. So what they have not DNS cache, let me call it DNS load balancer. We were talking about load balancer. So what it can have, that if the request comes for google.com, there is not just one IP. You have a set of IP address, set of URL, different URLs. And this will be smarter enough to figure out, okay, if the request comes from this particular place, let's route it to the nearest IP address or nearest CDN server. So like that, same concept works for DNS load balancer mechanism will be used with CDN server.
Can I interject?
Yes,
A
sure.
couple of quick things, right? So when you let's take a step back. When you go to google.com on your computer,
Yeah.
how do you know which computer to connect to, right? The very first thing is, if you look at your internet connection, you will have what is something called like the DNS Resolver.
Yep.
And that is something that is a service that runs on your local computer, on your router, or it is provided by your ISP, and they are responsible for translating a domain name, which is like google.com, to a IP address, which is whatever that you think that should be the computer that's backing the Google website. Now, in order for you to do that, typically, if you're like in India, you will probably use an ISP which is India based. If you're in Seattle, you'll use a Seattle ISP, and if you're in Germany, you'll use a German ISP, right? So those guys actually, what they do is they go and for every name server, so they have a cache, because more likely than not, many people are asking for Google's IP address. So they already know what that IP address looks like, and then they will send it to you based on what they have seen in the last, like, I don't know, 10 minutes, 20 minutes, one day, or whatever. There is a time to live along with that domain usually. Now, if they are hearing about this for the first time, there is nothing in the cache and whatnot, then the first thing that they will do is that they will find what is called the name servers for the domain. So whenever you register your own like personaldomain.com, you have to provide name servers to it. And name servers are essentially the authoritative elements that can give you or that can resolve anything.personaldomain.com. So Google has a couple of name servers, and those name servers would be like 1, 2, 3. You can specify as many as you want, but typically the general practice is to do 1 or 2. When you do that, the domain, the DNS resolver can randomly go to any one of those and ask for like, hey, which server what server is backing www.google.com? And the name server answers, and this guy picks the answer and continues. So the biggest advantage, or the thing that you can get out of this, is that the way the CDNs work is that it relies on the fact that you will be asking the closest, your ISP will be local, right? So they know that if you ask for google.com, then you will probably get an IP address for it, which is closest to you. So you won't get the actual server's IP address, but what you'll get is a local presence, local cache, or some local endpoint that is close to where you are. For Amazon, for example, this is like called a CloudFront. So you will get like a CloudFront IP address, which would be like hundreds of IP addresses across the whole globe. Your actual service may be deployed on 1 or 2 computers or like a handful of computers, but the CloudFront actually will front everything else. Yeah, Puneet actually has shared a TCP/IP guide for like how does the DNS name resolution work. I kind of like hand wave the whole process, it's very, very important to understand how this works. If you haven't done so, I would strongly encourage you to just go spend some money, buy a domain. These are usually like $1 or $2, not more than that. And then set up like a Cloudflare front for it. And then sign up for a free hosting and set it up from the ground up. And that way you will know what does an IP address mean, how does it work, and things like that. So I don't know if that I kind of repeated a bunch of what Roger said, but it's just more around. I think the sequence of how the data flows is sort of important for you to keep in mind, because there is a lot of caching that's going on at all the levels, and then there is a lot of data manipulation that goes on, in the sense that depending on where you are, depending upon who's asking and when, the information provided actually can vastly vary. So go ahead, Roger.
Hi, Vivek, I have one question. Just we talked about DSN, and then in the ISP, so CDN comes in ISP, right? So when we talk when we contact to ISP look for some cache pages.
No, actually, the DNS is provided by the ISP, not the CDN. CDN is actually, for all practical purposes, just a URL. It's just a domain. So it doesn't even have to have the name CDN on it. I mean, it's usually it's you can do it. You can have it as whatever, images.google.com or images.yourdomain.com can actually be a CDN. You can have it backed by CDN, but you don't have to have anything else on it. There is no descriptions or anything on it. The point is that your ISP does not play a role here, right? Your ISP's job, or your ISP may not even be in the picture. You can actually choose your own domain resolvers. Many people actually use 8.8.8.8 as your domain resolver, which is actually provided by Google. Or you can use I think 9.9.9.9, which is provided by something else. It's a few OpenDNS or something like that. So domain name resolving is something is something that is offered as service, and the speed of it is important. So different systems use different places for that. Now the key element is that when you get a DNS resolve from a specific geography, the DNS server can automatically choose to return that particular IP address that is closest to you for that domain. So if I ask for images.personaldomain.com, I might get a Seattle-based ID because I am Seattle-based, and it will probably maybe a San Francisco server will be sent to me. Whereas if someone from India is asking for it, maybe a Singapore-based server will be sent to them, and things like that. So it could be it is something that the DNS does, not necessarily the ISP. And most cases, ISP provides the DNS. So could be that.
Okay, yeah, thanks.
Awesome. Roger, go ahead.
Yeah, that's a very useful information. So look at DNS at your leisure. Also look at Route 53 or something from Amazon. I don't know why the name is 53 or something, but it's very weird. So you will try to
no, 53 is actually a port number for DNS services. That's a global port number for DNS services. That's why Route 53.
Oh, so 53 means something in...
It's a port number.
Oh.
Usually the DNS services are exposed through this port number.
Okay, that's the reason. Okay, I was thinking why this name is 53. That's good to know. Thanks. It was Puneet, right? Thank you.
Yes.
So what we were going through, we just went through the CDN server, I think. Okay, and we were talking about load balancer. So enough for that. Let's make some space, and then. So as you might know, in 45 minutes, what will you talk in your interviews? You have to really optimize your game plan. So currently you are just learning all the, not all, but a subset of the tricks. And then when to apply what, that's a totally different kind of session. Try to think about your strength, what you want to talk about. You can't talk about everything, and then you will not be able to build your actual system. So we're trying to look at all the components here in this session. So next thing I would like to bring here is, okay, so this server thing, how load balancer can assign different servers. Can you talk about, or can anyone tell me a scheme? like what kind of schemes we can talk, think about?
Hashing can be one. Something like use some ID, maybe, let's say
Okay.
a very simple rule would be, let's say first 10 clients would go to.
Okay. So suppose you have a client request ID, for example. So I know the request ID, and based on that, I can, okay, so there was one answer, round robin. Okay. Yeah, we can do round robin. And then another one was, if I have the request ID or some unique ID, how can I map it to the server? One answer was hashing.
Yeah.
Hashing. Okay. Then least busy. Okay. People know a lot. Thanks, guys. Least busy, content based. Yeah, we can, if we are using. So there are different kind of approaches we can do. Thanks for that. So yeah, all based on that, we can, do different kind of mapping. So we'll talk a little bit about here, in particular about hashing. So suppose I have 10 requests and we want to map it to 3 servers, S0, S1, S2. So what kind of function we should apply? We are talking about random hashing function, like, very brute force thing. So for request 0, I can map to server 0 maybe. We have S0, S1, S2. For request 1, I can map it to 1. For 2, let's map it to 2. And when 3 comes, where should I map?
We can use modulo, like whatever, 3 modulo, yeah, map it to 0.
Yeah, so you're on the right track. I just want to go there. So what we are deriving that, okay, we are doing modulo based on the request ID. So some ID modulo number of servers, right? This is n equal to number of servers, for example. So that is one scheme. It will also balance the things pretty evenly, right? If suppose the requests are of similar load, we can just evenly distribute it, kind of randomly. So like this, so this can continue to go on. Now the thing is there any problem with this approach?
So in case of failure, how this going to sustain? Suppose one of the node is failed and now your modulo is changed, right?
So one system fails, okay, then our modulo will change. And then what will happen if the modulo is changed, for example? So now I can start sending the request. So I have only 2 of these servers, right? So I can start sending 0 up to 4 to server 1, or let's call it server 0, and 5 up to 9 to server 1, right?
Yeah.
But is there a problem in that or not?
It's totally depend if you are sessionless and rest. Sessionless means you are not storing any state, then there won't be any problem.
Good. So what
I think somebody mentioned on the comment saying the load might be heavy on one of the servers.
Yeah, the load might be heavy, but still with this, we are after some time we have distributed the load evenly, right? Still we are handling 4 servers, like 5 servers and 5 servers, right? But what I think I forgot the name, Ronak probably. What he said that if there is something for a particular client, the request should go to the particular server. So basically, if there is some stickiness for the or let's call it affinity to the server for a client, then this might be a problem.
Yeah, Anuj had the same point, saying that if there is some state on the server, then we need to send the same user to the same server. So exact same point.
Okay, that's great. Anuj, thanks, Anuj. So as you can see now, the problem is this server like 0, 1, 2, like look at this. Number 3 and number 4 is being handled by server 0 now. Similarly, the same problem can happen. You start adding, suppose there is more load. So now you can't freely scale your service that easily. You don't know things in advance. Like suppose there is a big sale or something, you need a lot of server. Now you can't auto scale that easily. What will happen? Now the problem is all your mappings are kind of lost. Like now you have to start building that state from the scratch, which is a big problem. Is the problem clear, guys? I can draw, but I want to move to the next things also. So let me know. Is the problem clear?
It's clear to me.
Okay. So somebody wants to talk about where we are going now?
Is it like leaning towards that consistent hashing approach?
Yes.
Where ideally, I mean, I don't know if that's the point that we are trying to get to. But...
Yeah, that is where I am trying to get to.
Okay.
Yeah. So this hashing strategy had a problem, right? So why we make it circle? Because it makes things easier to look at. Suppose we had this server S0, S1, S2. We added a new server. Suppose we added a new server. We are changing mapping in all these regions. Like, if server 0 used to handle this much space, up from here till here, we had to make changes there. So every server had to make some change. But now this thing, consistent hashing, what it tells us, a different approach to map things. What it is telling you, okay, fix a point in this circle, for example. We know the mapping. We have used mapping also in a lot of other programming questions. I can map every value to a point in the circle using this similar hashing function. But now what we are saying, if you get to a point here, for example, randomly, a request is routed here. So this request should be routed to the server, which is towards the clockwise direction. That's one assumption we are making. So if the request is routed here, hash to this value, it will be sent to S1. If the request is routed here, it will be sent to S0 because S0 is towards the right direction from here. Now let's talk about adding a new server here. Suppose we added a totally new server. So server will also go through the same logic, like where to place the server. Suppose that got mapped to this particular place, S4, actually S3 here. So now what will happen? Who got affected? Let's look at it. S1 used to handle all the requests which were mapped to this area, this line, let's call it. I wish there was a color to change, but I don't know whether there is a color in Zoom. Here again, S1 to S2, they didn't get affected. They can still handle the request in this area. S2 to S3, now S2 used to handle from here till S0, right? But now he can only handle, or he should only handle up to this point. And the new server will be responsible for handling requests which are mapped from S3 to S0, from here till here, from here till here. So who got affected? Only this area, only this particular server, let's call it S2. So this way, what we are trying to achieve, that the servers which are affected are not many, just one server, or you can call two server if you include the new server which was added, but it was not in the picture, so let's call one server. And that is the basics of consistent hashing. Any questions at this point of time, or anybody see any problem on this in this approach?
How is the problem of that sticky session handled over here? Consistent hashing.
So we are talking about state. So your state S0 and S1 knows all the client requests between this range, right? Sorry, S1 knows everything from here till here, right? He will still handle the request for all those clients. So if there are some state, like, you have cached something or you have made some rules for that particular client, you are not losing it.
I think maybe a slightly different way of looking at this is that imagine if you had add the 4 servers, and instead of like if you now before you added S3, right? S0 was handling 33% of the story, S1 was handling 33% of the story, and S2 was handling 33%, right? That's how it was working. Now, in the previous model, what we said was when we added S3, we shifted everything to support 25%, right? That's kind of what we were trying to do. You do that, then the problem is that a lot of the customers will be affected, right? Because you're now shuffling something that was previously handled by S2 now will be handled by S3 and things like that. So that makes it a lot more confusing and very hard to figure out. In the new model, the S1 will continue to handle exactly what it was handling before, right? Because you're going clockwise. So anything that was between S0 and S1 will continue to be S1. The position of S1 is not changing. Position of S0 is not changing. So S1 will exactly handle the same thing that it was handling before. So is the case with S2. It will handle exactly the same number of servers as what it was doing before. The only server that is affected is S0, right? Of the half of what S0 was handling will continue to be handled by S0. But there is half of what S0 was previously handling, which is between S2 and S3, will now be handled by S3. So only that 16% of the customers are affected at this point of time. So it's not like everybody is affected. You are right. It is still the problem has not been solved. And that is a fantastic question to ask. How would you solve for that? Now that you know that which 16% of the customers are live, so you can do a few things, right? A few things are, number one, is that S3 actually understands which servers are actually, have been previously managed by S0. And it can use that to essentially either proxy it back to S0 for only those 16%, because usually when these customers are there, they are not long lived. They're usually there for like a couple of minutes, or like, the sessions are reasonably short. Or if you have a long lived session, then S3 can copy the data from S0 and say, hey, for these 16% of the customers that are currently live and active, why don't you state, like, replicate the state? I only have to replicate the state for 16%, right? Not more than not the whole world. So there are like a few strategies here. I think maybe going into details of all of those might be a little bit much for this session. Consistent hashing is the technique that Roger is explaining. But so you're correct that there will be some set of customers that will be affected. How to actually minimize that effect on those minimum set of customers is definitely a question.
Yeah.
Go ahead, Roger.
Yeah, totally. Yeah, question was really good. Thanks for the answer. So that's the idea I wanted to bring it up now. So consistent hashing tries to solve you the problem as Vivek already explained in detail. So now we have less affected requests. Still, we can have this problem of losing your data. So sometimes what you can have some replication that in practical situation, you can say, hey, actually, let me replicate the data which I have to the, the nodes closer to me. So S2 can say, okay, let me replicate my data to S3 and S1. So these are the optimizations which will make things better. Other things, maybe your one client is handling most of the sending you the most of the request. So it is possible that in your ring you will always get request at a certain point. So you can, sorry, there was a noise actually. Oh, it's okay. So you can try to, put servers at different places, so, but please go ahead. I wouldn't I would not go to the details of consistent hashing, but it is very useful technique. Read about it. A lot of databases uses it also. So since we were talking about load balancer, I thought this will be a good time to at least bring this to the picture. So with that, I think we can move to the uh, next topic, which I would like to bring. Is that good?
Hey, 1 second before you move on. Ankur, you were trying to speak. I just put you back on mute. If you wanted to speak, just go talk. Unmute and speak.
One thing I would like to add is, you generally put if a request comes for the first time, generally the server IP is stored in the cookie. So that's how load balancer can redirect that request to the same machine if it re-requests the same thing. If a client passes the request, so if it is handled by some client 3 or something, the server machine 3, that IP is noted down in the cookie. And so when the client re-requests something and another API or something, so the load balancer can inspect the cookie and redirect to the server 3 machine itself based on that.
So
wouldn't that be exposing the server's IP? That doesn't look, like secure.
what? Oh, sorry,
So they are not actually visible content. So they are actually they use hashing kind of. So that is a company's interoperable form. Its own proprietary format. You can use some hashing to get this data. So that this
It's
is
not
not
That's
visible.
correct. That is
Go
sorry.
ahead, Puneet. Go ahead, Puneet.
So what I was just saying is, yes, right, you can use cookies to redirect the thing and all. But the idea here is you do not need to be dependent on what you're storing cookie. Now let's assume that your cookie IP, the IP that you're saying, that machine is itself down, right? So that will put your entire session at risk. So what we are trying to say, discussing about the consistency, it is independent of whether you store that in your sticky session or not. You'll still be able to serve the clients based on some other server which can get the data for it. Does it make sense? Hello, am I audible, guys?
yeah, you're audible.
Yes.
Yeah, we heard you. Ritika, let me repeat your question and just answer that as well. So Ritika's question was that it doesn't make sense for you to expose like a company's internal IP address or something externally, because it just seems to be a little bizarre to surface that information. Typically, that's not what you'd do. You'd have like every server has some sort of like unique identifier or something which we can send. So essentially, it'll just be like server 1, server 2, server 3, just a name, node name or something, maybe a hash or something like that. It's not like raw IP address which can be used, but it'll be some key, some identifier that the load balancer can use to decide where to send it. I mean, it could just be like a unique ID, a GUID or something like that, which you can run through a hashing function and get the server if you want on the server side. So it's just like an identifier that is stored with a cookie so that it comes back with every request and you can consistently map it to the same server on the backend. Does that make sense?
Yeah, it does.
So S3, even in the internal, it still need to know the client IP address. Is that right? Because otherwise, how would it reply to the client?
Oh, no. So S3 is your servers, right? So S3 is here somewhere. Let's call this guy S3, right? This is your S3. So your consistent hashing algorithm could be here in your load balancer. Some of the load balancer, you can go and check whether they provide this algorithm inbuilt or not. Actually, they do. So load balancer will handle the communication. Like there should be a mapping where this request should go to. So still, load balancer will handle that. Is that clear?
Yeah. So if that's the case, if load balancer go down, then
Yes,
it's not gonna
right.
communicate back to the client.
Yeah. So somebody had asked this question and we totally forgot that, okay, you will not have one load balancer also. We should never have a single point of failure. So you will have multiple load balancer. And let's talk about the topic shortly where, like, maybe in case of, we'll talk about it also. Let's keep it. So you may have this. Now the question is, when should we use one load balancer versus the other? Can we use two together? Things like that. But
So one.
yes, yeah, load balancers shouldn't be a single point of failure. And when you use cloud services, you get this, all this thing is for free. That's why, like, people use cloud services. You don't have to worry about all these things. Okay, so now the next topic, since we are talking a lot about distributed system and we will use it in most of the like system we are trying to discuss, is cap theorem. Let's talk about that. I will take a like 1 minute break and you guys can continue to talk. Whoever knows about it, please go ahead and talk a little, and then I will go through the diagram and I will try to explain.
Yeah, so does anybody know about the cap theorem? Anybody at least heard about that?
Yeah, I mean, I just know a little bit about it. So I guess like it kind of stands for consistency, availability, and partition tolerance.
Yes.
And what we are trying to say by that is you can only have 2 out of 3 at a, with a given architecture. So if you want to have a partition tolerant system, for example, then you can either go for consistency or availability, not both.
All right, I'm back. So
Okay.
consistency, availability, and partition tolerant, right? Somebody was talking about that.
Yeah.
So great. So let's talk about like these things. What do they mean? I will draw a diagram. Let's build a network. This is the network, and let's also make this thing. So what does consistency means? Like these are all nodes, by the way. So you can think as a server. If I write something here, I'm writing some value 5 here. And if I'm reading here from another node, I should get a value which is greater than equal to 5. That is consistency. Is that right? Why greater than equal to? Because somebody might have changed that value also, right? Some other request came and then it changed. So consistency means that whatever I am writing, I should be able to read this, like, a greater or equal version. So that's the C. Let's write it here. Consistency. Now we will talk about availability in this simple example. Sorry for the bad handwriting. So availability is same. Okay. So if I'm making a request here, I should get a response from this node. If that node is like, alive, at least. So that is okay. My system is available. I can say, okay, I made a request. I got a response. That means my system is available. And then what is partition tolerance? Partition tolerance is, in this case, suppose there is a network failure. So your system is now like, divided. Whatever claim you have made about the system, like suppose you said, I have a highly consistent system, or I have a highly available system, then that claim should hold true. That is your partition tolerance. Because network go down. Okay. So your claim should be like, when you will build, like people say, okay, build YouTube, build whatever. So you have to talk about all these things, like what you want to actually go for. So what CAP theorem says, now can someone say like, what is the actual theorem? We just talked about these things in short, but what is the actual theorem? This is just definition.
That you can only have 2 out of 3.
Okay. So out of these 3, you can choose 2.
Mm-hmm.
That's the theorem. Like out of 3, you can choose 2. Now let's have a quick proof of that, why that is true. Okay. So let's only look at 2 nodes. Suppose I did write 5 here and the request came here. I was able to read 4 because of the network partition. I was not able to communicate. So you can have a system where you allow to read old data. So in that case, we can say, hey, actually this system is not consistent. Can I say that? I did write 5, but I was able to read only 4.
Yes.
Yes.
So we will say it is not consistent. Okay. Other case could happen like, okay, let's have this here, just 2 nodes. You did write 5 here still. And this guy, he knows that actually I'm not sure what is the state. A request is made actually, but this guy is still waiting to communicate with its peer to get the the actual result. So what it does, it continues to just check and times out, and it actually doesn't give you the actual response, because what he's saying that I will either give the right result or I will not give any result. So in that case, we can say that our system is not available. Is that right?
Yeah.
Yes.
So we are not available. The other case could be like this. You did write here 5. And then there was no partition. So these guys can sync up. And we made a request here as usual. And this guy returned me 5. So we are available, we are consistent, but we have made this assumption that, hey, this link has to work. So if we are making that assumption that this link has to work, then we can say that we are not partition tolerant. Does that make sense?
Yeah, it does.
So that's like quick proof of CAP theorem that you can choose 2, but you cannot choose all the 3. So like in any case, you have to make a sacrifice. You have to sacrifice something basically, and this will be very important for most of the interview questions where you have to make that choice.
I have a question on the second case.
Yeah.
Why it only not available? Shouldn't that be also not consistent too? Because we have network partition.
No, it is not consistent. It is still consistent. It's only that you are not able to get the data. It's not giving you the wrong data, right?
But there's a network partition there. How do we know that they all have the same value?
What was your question? If there is a network partition, yeah, can you?
Yeah, on the example, the second example, right? There's
Yeah.
a network partition there.
Yeah, here, yeah, there is.
Right? Yeah. So how does the left node communicate with the right node and say, all of them have the same value?
So like, let's not go into implementation, but still, like, trivial way could be, it tries to communicate with all the servers that what is the value. Like suppose there are two, system which may make a change. It will try, hey, I have this version 4. Have you changed this version to 5? And this will, so that is why when you try to build a consistent system, it becomes slower, because now all the guys who are responsible for answering your queries, they have to coordinate before giving you the exact right result. So that was the problem he got trapped here in, that I can't communicate with the other guy who can make change. But mm, I don't want to give actually the old stale result in any case, because that's what I have claimed, that I will be consistent. So he sacrifices his availability for that particular reason. Is it clear? Or can someone else explain in a better way?
So essentially what is happening here is you take assumption of one of the things and try to prove that other two are possible or not. Like in this case, what Roger mentioned was network partition. So let's assume the network partition is fine and everything is going good, but then you will have availability. Like if, in this case, he was trying to contact to the other partner and trying to find out whether he has an updated entry or not. Now, if it's not able to give you answer, that means there's something wrong with the network, right? And in that case, what is happening is you get some response or you don't get some response. There are only two conditions that can happen, right? Based on one of them, you will have to sacrifice the availability, right? And what will happen is if you don't get a response, you will not respond to the end customer. Does it make sense? So in that case, you are, sacrificing your availability aspect of the CAP theorem.
Okay, so you can continue to ask in our forum, if there are more questions, we can look at it later. But yes, that's the basics. You will not be asked the proof, but I just try to demonstrate so you remember for a longer time. This is very easy to come up with.
I'll share a link on the Slack also. There's a good kind of case study which proves all the three things, but I'll share it on the Slack channel.
Great. Yeah. Please continue sharing all the things which we are discussing here. We'll get into the detail. Everybody can read that later. Thanks. So now,
I have a question.
Yeah, go ahead.
Yeah, can we ever sacrifice on the network partition?
Yeah, that's
that
a good.
not in our control.
Yeah, that's the good thing. Like, can you sacrifice network partition? Actually, that is not in our control. That's the problem. So that's why most of the time you will choose either between consistency versus availability in most of our systems we will design.
Yeah, just one question. If you say you are sacrificing network partition, what are you essentially trying to say? You're saying that everything is in a single box or a single data center where there's no network connection, right? That kind of you are moving away from a distributed system to a monolithic application.
Exactly. Your database basically is highly consistent, but actually it's not partition tolerant at all, right? RDBMS in the beginning we used to use. So we will focus on these.
Yeah, that is how they are able to maintain that consistent and available approach. Like you get asset properties and completely in a single RDBMS server.
Yep.
Okay, so I get the choices always between C and A. Like P is we have to.
In a distributed system, yes.
Yeah, like this cap is for distributed system only. I think.
Yeah, because if you're saying network partition is something that you cannot tolerate, then you're saying you're on a single box or a single machine with no network connections. That's not a distributed system.
Okay.
All right. So we had a a little bit theory of cap theorem. We will use it a lot in whenever we design a system. So now let's erase it and let's talk
Hey,
about,
just one thing.
yeah,
I just wanted to add this to cap theorem because this is something which I have,
yeah,
often
sure.
confused the cap theorem as. So what cap theorem essentially says is you cannot have 100% guarantees on these things. You cannot be 100% consistent, 100% available. It does not mean that you cannot be 90%. It does not mean you cannot be 80%. So when we move forward with different approaches and different ways, we'll see there are ways where we can be somewhat consistent, but not 100% if we still want to have availability. So something like eventual consistency and all, which we'll discuss later. But just at this point, you just have to keep in mind that these are this theory essentially says you cannot be 100% guaranteed on these things while not sacrificing anything else.
Yeah, that's a very good point. Thanks for bringing that up. I totally forgot about it. So a lot of systems you will actually mostly go for eventual consistency because many systems, they don't care whether you have the always 100% right result or not. You can wait for a couple of minutes or a couple of seconds or even for more time, depends on the application. But what that guarantee, hey, not today, not now, but eventually I will get to this consistent state. So if I have to choose between consistency and availability, I may choose availability, depends on the system. I'm not saying always, but most likely for many systems, I will choose, okay, I want to be available always, but if I have some inconsistency for some time, that is okay too. So that's what Puneet was talking about. So we'll build a lot of systems which will be eventually consistent system. So with that, I think we have touched the surface of cap theorem a little bit, and we can go to the world of databases. Is that okay?
Yes.
Okay, let's erase it. So let me make some space. So which kind of databases you guys have used?
MySQL,
Okay.
Oracle.
Okay. So both RDBMS, right?
Yeah.
Okay. So let's put in your service now, you need to start storing a state. So maybe you have this kind of database somewhere.
Oh.
You can again have a load balancer here, by the way. Like if you have more databases, you can have a load balancer here. So the request can go like this. So we'll talk about this guy now. So this is where you store your state. Now we have RDBMS, and nowadays we talk about NoSQL database. So RDBMS, what is the benefit of RDBMS? Can anyone quickly talk about it?
So we have a defined schema, right? We have a structure for when we try to load data into the database, we conform it to a structure, right? So we can have constraints and we can ensure that the data is clean. But in NoSQL, any Hadoop or any other system, I think we try to just dump data as is and then try to query or parse it when we are actually, submitting some query or
Yeah, good. So NoSQL, we have
we do have a schema up front.
Yeah, schema. And you also talked about Hadoop also, right?
Yeah, right. Any non-RDBMS system, I guess they don't go with schema, but RDBMS have a schema mandatory.
Yeah, that's a very good point. Thanks, Deepi.
Yeah.
So that was schema. And then you might have heard about ACID guarantee, right? In RDBMS.
Yeah.
So go ahead and read it because it will take too much time to just go into the detail, but it's like atomic basically atomic means like we either do something or we don't do.
Right.
Then it is consistent, which is like a valid state. Then I means I think isolated.
Yeah.
Which have again now 5 or 6 transaction levels. You can make it serializable and other things you can do. So it will feel you that actually it is almost sequential from client's perspective,
Right.
but it may not be. And then durable. Durable means it's permanent, right?
Right.
So that's where RDBMS science, like that's the core thing. You will not duplicate the data because now it is a relationship. So it's normalized, right? There are different level of normalization also. In your college, you might have read about it. I vaguely remember there used to be first normal, second, third, and another BNF or something like that.
Right.
But basic thing is you have a schema, you adhere to a rule, and then when you have to get some value, you will do a join, right? Join operation.
Correct.
So you will have a key, primary key, and then relation with other key is determined with a foreign key.
Right.
So yeah, that was the case. Hadoop is totally schemaless. So there is no schema there. And NoSQL has different kind of databases. I think, let me try to, there is a I can send you a link. I haven't read about it, but let me remember. There is one key value pair is the basic one. Then there is a document store. Then there is a
Key
column
value, document store, column, white columns, and
graph.
Graph TP.
Yeah, these are 4 major things. So the key value store is very straightforward. You put something, some as a key and get value. You can put anything basically. So now your application should figure out what does that mean. So from database perspective, you are dumping things, and then application which is dumping thing will get that value and figure out, make some sense out of it. It may it may also store maybe, for example, something which can try to help it deserialize the data, right? So that kind of logic you can apply in your application layer, in server layer, if you are using key value store. Does anyone remember any key?
Okay, I have a question.
Yeah.
So, like RDBMS is fine. Like you say the schema. Here you are not telling a schema, and you are dumping everything in that database. How it is like just from RDBMS perspective. Suppose there is some ID, the customer ID, what he bought, and what is the price of that whatever he bought. So
Yeah.
there is a row. Here, how if you dump the customer ID and the item ID and in one row, and second we dump customer ID with the what is the price of that ID. So how it will differentiate? Anybody?
So again, somebody is.
Yeah, Roger, can I go ahead?
Yeah, go ahead.
Yeah. So first of the thing, then when we are looking into a NoSQL and RDBMS world, we have to forget about this columns and the structure, right? So because that's what it's stuck into our mind. The database is itself a table structure. One thing is that. Second thing, when we say there's no schema, it doesn't mean that the entire application does not have any schema. What we say is the database storage unit or the DB database management system is offloaded with that responsibility. It does not need to care about the schema.
Okay.
But that still doesn't mean that there's no schema. What it means that the schema responsibility or how to interpret the data and how to respond to the end customer lies with the application now. So to answer your question now, let's assume you have 2 JSON documents. So that is one of the document, right? In one JSON, you're saying ID and price. In another JSON document, you're saying ID and something else. Let's suppose first name.
Okay.
Right? When you respond back, the database management system will just give you 2 JSON files, right? Now, how to interpret it, whether you want to only take the IDs, you want to scan it for IDs and price, that is what your application has to decide.
Okay.
Right?
Okay. Okay.
Yep. You got the idea, right? So
sure.
So you have offloaded things from database, so it's very performant, right? Database is not worrying about all these rules, so that's why it's pretty good, in terms of performance. Question is a couple of key value pairs, key value stores. I don't have example in front of me, but I think document DB or DynamoDB used to be, but I think
Redis cache is one of the key value pair.
yeah, Redis Cache is definitely one. Redis Cache is there. And then DynamoDB used to be key value, but they also started supporting document, if I remember well. So
MongoDB is document.
MongoDB, yeah. So go ahead, take a look. A good, go ahead with all these. Somebody, let me try to mute someone.
I can give one example for each key value Redis. Document this MongoDB is document. Graph is Neo4j, and for column store you can look at Cassandra.
Okay, so in document DB, what should I write?
MongoDB, or you can write Cosmos DB.
Yeah. MongoDB, yeah, Cosmos DB I have used, so yeah, I know that. Thanks. Cosmos DB used to be called something else. Document DB.
It was called Document DB. Yeah.
Yeah, it is Neo4j. And then columnar is, what is the columnar database?
Cassandra.
Okay, Cassandra. Okay. So now the problem with key value store is, if you want to make some sense out of this thing, you will have still, same problem. You will have first name, last name, age, social security number, you will not store social security number, but maybe salary, that kind of thing. So one very useful thing which database has to give, that, hey, if I want to search some information in a faster way, I should be able to do that, right? So in RDBMS, suppose you have to search faster on a particular column name, I want to always search by first or last name. Then what do I do?
Indexes.
Perfect. So you apply index in RDBMS, right? So what index does, it stores extra information, so what it will do, that your write will start to become slower a little bit, because now it has to write more, it has to work more. So you may apply index to maybe whatever important properties you have in your different columns, but you will not apply in everything, because then your writes will become super slow, right? So now I can't do that in this case, right? But if I use document DB, so document DB can have some schema. So it's not that you will never have a schema. You can choose to have a schema, but you don't enforce it. So if you can do that, then you can still get things indexed on the attribute. So what these stores, MongoDB or Cosmos DB, they will allow you to apply index. And we very sure, because I think at one point of time I did see that Cosmos DB most likely it allows index by default. So if you have 50 columns, it may apply most likely the index on each of those. And then there is a concept of range index and that kind of index. We will not go into the detail, but what it allows, you can apply index, you can adhere to some schema, then you can actually make sense out of data. You can serve some search query in a faster way. So that's the purpose of this second type of document store. Third is columnar. So columnar, does anyone know how it works?
So it is a wide column, and for example, like in the system where we store the images.
Mm-hmm.
So columnar will have an means they can store the images in the wild columns. Means in a HB base.
Yeah. Yeah.
That and we can store with the ID. Means like an means in the main database we will just store the URL for the image, and the main URL we can store in columnar.
Okay. So columnar, as the name represents, you are interested on a particular column. So suppose in a table structure, we can have like, our rows like this, like there are hundreds of rows, for example, but you care about like these two, say these two only for your queries, of course, and you are analyzing your data, like, and you need fast, like, fast query here. So even if you apply like indexes on this, it still goes through, like, it has to go through all the rows, like in RDBMS cases. But columnar, what it does, it tries to have all these like columns as a document or as a like its own entity, independent of other entities, kind of that concept. It's not exactly that, but that allows it, instead of these 100 rows, now you're only looking at, sorry, 100 columns, you are only looking at 2 columns. So
Something?
yeah, go ahead.
Yeah, columnar DB is something like this one. So you can, one row can have 5 columns and another row can have 8 columns. I mean, the number of columns between rows to rows can change. That is actually like columnar database. I think you are talking about the Vertica DB or something like that, where columns are stored together as such.
I think, but you are thinking these are schema-less, so you still not can have like, everything populated in every column, right? You can have a default value or null value.
Yeah, you generally don't have the, I mean, it's similar to row itself, but the rows can have varying number of columns. That is what columnar database means. So, yeah.
Yeah, I think
That's correct.
I think there are two kind of, I don't know like the exact terminology difference, but coming to what everybody is saying here. So yeah, there are two different paradigms here, right? So one is when you don't have, so Roger, what you are explaining here, that would be like you are actually, rather than reading the whole row, you are just reading the required columns. That's also a concept that's actually used in an RDBMS with Microsoft SQL Server now. They have clustered column store available, and they follow the exactly same concept. But the other concept that somebody was mentioning was when you don't have a fixed, like, like schema per se. So first row can have 5 columns, another one can have 10 columns. In that case, that's a little different variant of, this terminology. But I think that's what Cassandra follows, that you have these different, varying number of columns.
Okay.
Yeah, it's a kind of an overloaded term there, according to me.
Yeah. Thanks for like explaining.
Columnar database, and this is wide column database actually.
Right. So yeah, from if we are going with that definition, that interpretation of, different number of columns and wide column, all of that, I think that's the one Cassandra follows. But
yes.
Yeah.
So for like, this discussion, please, the idea is, thanks for like, participating. Go ahead, check this, and then check also wide column, because things are so like, there are different implementation. So wide column database, look at it. Look at columnar, look at Cassandra. So I haven't gone through that recently. I vaguely remember the concept. So we'll go ahead with that for now.
Yeah, sure, no problem.
Does that make sense?
Yeah.
Yeah, just because in favor of like other things.
Sure. No, that helps. Thank you.
Yeah, same with like, graph database. These are pretty new. And as much as I understand, this is the thing which actually requires more relation. Like, as we used to have some relation in RDBMS schema, that is where the graph database will shine. I haven't gone through that, but this is the example for Neo4j. If
So
somebody has used,
I can just add one quick note on this,
yeah.
just as at an introductory level.
Mm-hmm.
So the biggest difference I see between graph and RDBMS is coming from like the concept of joins, right? In RDBMS, the one of the kind of challenges that we see is that when you do joins over, large tables or multiple tables, that's done on the fly, right, at query time. And that makes the runtime and that adds to the complexity. But in graph databases, you are actually, by just the nature of the graphs, you're actually materializing the joins in the form of having edges. So you are not doing the joins on the fly. You are essentially having the joins in the form of edges right there in the graph, and you're just at the query time traversing your graph.
Oh, got it. Yeah, it's a very good concept. So you have that edge already being built as you are working on it. Yeah, yeah, it's so amazing. So that's a very good thing. Maybe for future, we'll see more uses of it. So that's Neo4j. So now with that, should we? Okay, so when should I use like one versus the other, like RDBMS versus NoSQL?
I think one is of course, coming back to the basics of like do you have a flexibility of having a schema? What the use case is, right? What is your application use case? To me, that's the one key point when I choose one versus other. And of course, RDBMS, there are other things about, if you're having a single node configuration versus scaling issues, that might be another factor.
Yeah, the schema, you will look at like, your read and write queries, how many read write, the percentage of it, and that will help you choose one versus the other.
Right.
So with that, we'll go to the next topic. Hopefully we can work on now. What is the next topic we should have? Maybe either we can talk about caching now, or we can talk about sharding now. What do you prefer? Let's talk about sharding then, maybe, or maybe caching is also. Let's talk about caching.
I think we should go with caching. Yeah, because sharding is going to take a lot of time.
Okay, so let's talk about caching. So now, suppose you are making a lot of queries to your servers, and when do you use it? First of all, cache. When do you use it? So you have different servers. You are making a request to these DBs. You get the data, for example, and you return it to the client. If you know the data is not going to change, for example, that could be one use case. Or we already have something just calculated, and it's okay to give stale data for some time. You can choose to have that here in your application server level. You can have that in your application. You will check before making a call to database, because you are making a network query. So this will become very faster. Your database will have less load, and the request will not even go in this direction. It can just start to return in the opposite direction. Like, you will return the response. So that is how you can build a simple cache. So the way I have built, I am calling this cache. This is cache. This is cache everywhere. So all these servers have their own cache. Do you see any problem with that approach? Or question about cache, basically?
Would there be an issue with cache synchronization? Like,
Cache synchronization, what?
So I'm thinking I'm thinking of this concept like, with even on a single system, right? When we have multi-cores and each core has its own cache. So if a request comes to, like, even sticking to this one, so each has its own cache, then when a request is made, if for some reason, one of the cache has evicted certain elements or it's stale, making sure that other servers at the same, because the
Yeah, that's
request will
actually
be
a,
served
that's
from
actually a
cache.
good question.
Hmm.
That's actually a good question, but for now, I think let's assume there's just reads and all. There's no update going on because what you're saying is a topic for a discussion in itself.
Right.
You know, how to update cache and how to make sure that the caches are always synchronized and updated.
Okay, we'll talk about that. If that was the thing, yeah, we'll talk about now. It's a very basic question I'm asking at this point of time. So, anyone has any problem you see with this?
Coherence caching.
What is that? Coherent caching? What does that mean?
So basically, right, so if you have 10 servers and each server is having some cache at JVM level or a server level, so if the servers, I think if they are in distributed, right, so there is a coherence cache, like take a in WebLogic, I think you can enable coherence caching. So the elements that you keep it in the cache, those will be across cached across all related environments.
Okay. So that's the server level thing, but what's the problem could be like? Suppose the request came to server S0. S0 has this cache response, for example, but next time a request came to suppose S5. It
Oh,
is
right.
already cached in S0,
Right.
but we are not using that. So all these servers, they may have a lot of caches to their peer already have. So they are duplicating it.
Correct.
Right? So what you can have in this particular case that you don't store the cache with you. That is one possibility.
Mm-hmm.
And then we can use distributed cache, and how to build a distributed cache will be a question in itself. But for now, let's try to use something which is built, something like Redis. So now all these servers, they can actually, for cache, suppose this is the distributed cache, this cache. So they all can look at it, right? Hey, is this here? If this is here, then we will not even make a request to the database server and we can return the response, right? So that will solve that problem. So you have one place where you will have cache.
Question, if we do a distributed cache, right, so we are doing another network hop, right, how that will be impacting performance if we go for the distributed cache with the local cache, general point?
Yeah, so by the way, when we are talking about cache, think about what is not cached. Let's talk about the hardware. You have on hardware level L1, L2, L3, different type of cache in your ROM. Here you will also have some caches for sure. You can have manageable level of cache. Only your storage increases as you are going far from your place, right? Web browser has its own cache. Application server, sure, at JVM level you may have your cache, but how much you can have? Like you have some memory limit also, right?
Yeah, that's right.
Yeah.
Yeah, so other than distributing and not having, you have other problems also, right? So in that particular case, as you are going far from your location, you can choose a better or bigger cache. Now, not only that, like Redis cache, these kind of things are optimized for that particular case. So you will have SSD. So it's pretty fast. If you look at, actually, there is a very good page, something every engineer should know, from some Google guy, like numbers every engineer should know. Search for this. It will talk about all these numbers. Actually, Jeff Dean or someone has written this. Engineers should know. Can somebody post it also? There you can calculate, yeah, like cost of each things in relation to the other things. So, okay, that's the thing. We have caching at each level. we just came to the distributed cache here. It solved at least one problem. It is optimized for that. So we'll make less database call.
Can I just add one thing, Roger, here?
Yeah.
Just one comment about one question that we had about performance.
Yeah.
The way I see distributed systems is usually you're trying to make a trade-off, right? You're trying to balance things. Similar to the idea we had with CAP, right? You can't have 100% of everything. So one of the advantages I see with separating, the cache is also, I'm trying to think of mapping it to an paper I read. So recently Microsoft published a paper about Socrates. It's the Azure, their database service, and they have decoupled storage with compute and stuff. So if I look at it from that point of view, when you separate your cache from the servers, let's say servers have certain compute power, then you can scale it differently, right?
Yeah.
But if I just integrate it, then it kind of, tightly couples my system.
Yeah. What is that called? Just for curiosity.
Yeah, it's called Socrates, Socrates.
Okay.
So it's a 2019 paper, and that's where they have taken this approach of decoupling storage and compute.
All right. Yeah. Thanks.
Yeah.
So now for caching, now we can talk about some of the things which you guys were talking. What is the behavior during read time versus write time, and how we can have it in sync. So I will take, I have to grab water. Give me 1 minute, and in that time, please continue the discussions.
If we have any
questions, yeah, that's what I was saying. Any questions so far?
On any other topics from the start of the session till now, if there's anything you
So
can...
I have a question like why NoSQL is preferred for read calls and RDBM is for write calls, like that's not a script. So
can you repeat the question, please?
Why NoSQL is preferred for read calls where more read calls are there, and the RDBMs are preferred when more write calls are there to the system?
Did we discuss this point or you got in your chat? Because there's no silver bullet if we say that RDBMS is for writes or this is for reads. So essentially, as you said, RDBMS is more or less when you want a very consistent data at the real time. But if you can tolerate some of the delays inconsistency, you can even have writes on a NoSQL database.
Okay.
As Roger earlier mentioned that if you are okay with having some delay in the data being consistent, you can have other options of delaying the consistency, like eventual consistency and all. In that case, you can also have writes in a NoSQL database.
Okay.
RDMS has its own benefits as compared to NoSQL, like the consistency. So it depends on the use case scenario and the requirement. You might want to choose between a NoSQL or a SQL, or have a hybrid of both of them.
Right. Yeah, I agree.
So one thing is if the write volume is huge, you generally go with NoSQL. The data structure, how RDBMS handles the data input versus how NoSQL, there's a difference in how these handle the writes. So that's where if writes are used, generally you go with NoSQL kind of databases.
Is it opposite? Like what is?
No, I think it goes back to the point, right, of the use case. So one way to say, when you say writes are better in NoSQL, you may be coming from the point that since it's schema flexible, you don't have to add all those, because the moment you define a schema in RDBMS.
I was actually referring to write volume actually.
So
yeah,
okay, sorry, I'll just put it on there. So let's assume two examples. One is Twitter feed and another is a banking system. So even if your writes are high, you might not want to have a NoSQL database writes because you might have inconsistency in data between the time you'll have, eventual consistency with different nodes. So banking system being, many they need to be very concerned real time. You might not want to have writes in a NoSQL.
Right.
So it again boils down to anything what your use case is, what level of consistency, availability, and all those cap systems you want. So the banking example is one of the things where you have a lot of lights, but you still don't want to be in a NoSQL environment because of the consistency delays.
Mostly it is a consistency based, like if you.
And there is one other thing in terms of performance numbers. So if you go to the benchmarks, right, they are the most objective, one of the most objective ways of quantifying, right, which one you will choose or what are the capabilities they can support. So if you go on tpc.org website, it shows how, there have been results over 100 terabytes of data with RDBMS. With data writes and updates and all that. So it really depends on the underlying hardware you are using and the use case that we just I think Puneet was talking about some examples. So yeah, that's how I look at it. But
Okay, guys. So
okay.
Good discussion. As now you guys can talk about that, we can start system design and we can continue to talk forever because there is no right or wrong answer, right? It's all depends on the way we are looking at it.
That's true. Yeah.
So we'll continue our discussion that now we have the cache. Now we can have either write or read on the cache, and what are the possible ways to have your cache, when you have to invalidate things, and there are different approaches about it. We'll just touch it a little bit. So reading is very easy, right? Whatever is in the cache, suppose there was no write, then you can just return it. But the things change when you start to write it, right? Because it changes things. So when things change, yeah, you can go ahead, Puneet. Thanks for your help. So when things change here, like what does that write through means? Can somebody tell me? So a write came, what we will do at cache layer?
Write through would write it down to the backend.
Exactly, write through. So you write to cache and you write to DB. You write to both. So they are always consistent here, hopefully. The other approach is okay. And what is the
I have a question.
Yeah, go ahead.
So so let's say server 1 does a write through to the DB. How do the other servers know that the content has changed?
Can you repeat can someone else repeat the question if you understood it? Sorry, I can't hear it properly. Please.
So let's say I get a write through request on server 0, right?
Okay.
And I write through to the database. So I change the value in the database. How does server 1 know that the value has changed?
So, okay, bear with me. So let's go step by step. So S0, suppose the value was 4. I made it 5, you are saying, in the cache, right?
Yes.
Okay, and what next?
So after S0 updates the backend.
I didn't get, sorry. Can someone else please explain the problem? Or can you type it?
Yeah, I'll type it.
Yeah, please, you can continue to type it. I will come to it later, but let's, yeah, we will go through that benefits or what is the problem with this approach. So now all my actually writes are slower if I'm writing to two places. I'm writing to cache as well as I'm writing to the DB. So all my writes are actually slower than just writing to database, but my reads are still okay. Okay.
Are we writing one at a time or write to both, simultaneously?
I think he's alluding to the parallelism concept, maybe. Like,
because we go one at a time, or like we have to write to the cache and make sure that success. Then we write to the database and make sure it's success, and then we return success to the client.
Okay, so the previous question was S0 writes to cache. Okay, S0 updates the backend. Okay, that is fine. How does S1 know that the value has changed? So if we have updated the cache and S1 is actually going through, it's not going to its own cache, it's going to distributed cache. So we already talked about that scenario earlier, if you remember. So we are going through this distributed cache at this point of time. So it will get the latest value. And if we are following right through, we'll always have the updated value because we are sacrificing time to update both.
Yes, but my question is, if we write it to the cache first, and then we write it to the database, and then, when we have not write to the database, and S1 access the cache and get updated value.
No, it happens at the same time. Like, it happens parallel, so as to speak. It's not like one gets updated and other doesn't. I don't think that's how it works.
Yeah, so the thing is, this is again, both the systems, something can fail. So now it depends how you can make it like you that way. You can do something. First update the database, because if you update the database, even if your cache doesn't has it, eventually a read will bring it back, right? There will be a cache miss, and then that way may bring it back. That's possible.
I think it depends on the policies, that goes into detail, but there can be different ways. You can maybe have some algorithm to make sure that it's atomic, right? That make sure that it updates both, and only then you get an acknowledgement or something.
Yeah.
Yes, that's what I try to clarify, right? So why, let's see, why in the transaction is not committed, totally committed, then whoever, access the cache still get the own value.
No, but even cache won't be updated. If there is a problem that happened while writing to the database, then it's not like cache gets updated and database is not. Like, it will be like an atomic unit.
Okay.
That's what my understanding is, but maybe we can check and maybe post on Slack.
Yeah, I mean, you will have to, like, if you have to really keep it consistent,
Yeah,
you have to figure out a way to do that. It's like when there are two resources distributed, problem can happen. They can go out of sync, but it's a different discussion. So right through, we talked about, okay,
can you hear me?
Yeah, I can hear you.
So what we are discussing here, so let's say if I have 100 million records in my database, I'm loading 100 million in my cache or partial set of that? This question.
So then you will have to have some eviction policy, right? It depends on your cache, size you can handle.
Got it. Okay.
Yeah, we can't write all the data to cache.
Yeah, that's okay.
Yeah. So then you will have to also think about eviction policies. We'll not go in detail, but yeah, there are different LRU, LFU, first come, FIFO, LIFO. You got the idea, right?
Yeah.
So let's go to the second one. So I think we talked about write through, we write to both. Write around means that you only write to the database. So if the request came here, if it is not in the load balancer, in our cache, we just update the database. So we are not doing two writes. We are not updating our cache server. But what is happening, we know that we know that whenever a read comes, it will automatically bring this thing to the cache. So we have deferred to the guy who will read next. Does that make sense?
So we we have to clear that entry in the cache first, because because
so you are
later
always
when they
updating database.
go and then they're gonna go to database. Otherwise, if they see in the cache, they're gonna return it back.
Sorry. Just a minute. Can you see my screen still, or
no.
Did you miss? Okay, maybe I was disconnected for some time. Okay. Yes. So what was the question? That what steps you take? Your request came to this server, for example. Okay, here. Now it's a write request. What I am doing, I will just go and put in the database. I will not go to cache.
Yeah.
What will happen if somebody is looking for that entry as a read operation? Then it will first look at the cache. If it is not there, it will update the cache anyway.
Correct.
Right?
Yeah.
So your cache will get populated on demand when it is required. That's the right around cache.
Yeah, that's right. But let's see, suppose the cache already there. I mean, the value already there in the cache.
No, then you're talking about updating. You're not talking about writing new data, right?
Yes, but it's the same thing, right? We write through around. That means whenever we update, suppose that entry already in the cache, and now we update the database, then somehow we have to say, okay, we have to notify the cache that, okay, that's the value have been modified, so the cache can get the
stale data,
the updated value, right?
We can implement some observable design pattern and look for the database with the modified timestamp and load it in the cache incremental.
So exactly. So see, anything you are talking about here, it's not a perfect solution. Just always remember. But yes, now this is the problem. Now you are choosing that, hey, actually I need faster access. And maybe after some time there will be some job or something which will refresh my cache, for example, or all the stale data get refreshed, or maybe my system doesn't matter, I have a TTL for the cache also. Like if this guy is stale and there was no request for last 15 minutes for this, remove it from my cache. You can have that kind of policy, so you will not have the stale data for a longer time. Does that make sense?
Yeah, that's actually one of the questions in my interview, and then the interviewer will ask, okay, I just update the cache, and now I go to get the value, and now it return me the own value.
Yeah, that might
because
be a
that
downside.
if we use a time to live, then that's not gonna get the latest value, right?
But if you want that, then you can choose this one, right?
Yeah, right. So just to reiterate, right, this write around is just one approach depending on the use case of your application. If you can compromise that, like the stale data and all of that, then maybe you will consider that. But you don't have to, right? If your requirement is you always want that the most recent updated data, then you may want to go with other approaches out there.
I know, but in the context of the it might not be, but in the context of the interview, they were asking for write through and how would the cache get updated.
Yeah, so it might, I think I'm going back to that observable idea, that observable pattern. There might be a trigger attached, but it goes back to the, maybe somebody else. I don't know how
So what the thing is, any basic thing which depends on this idea, or we can, because it needs context also, in which context we are trying to solve the problem. So we'll have to ask you many questions to give you the better answer. So feel free to post it into the design discussion, whatever was asked, and then people may chime in and we can figure out what we can do. But what we are talking about currently is just the possible things, what is good in one case versus the other, what we are losing. Write around is good for faster write, right? But it is not that consistent, because now we have some stale data in our distributed cache even.
Yeah, right.
So you can choose that. Different applications may have a different design choice. Similarly, another thing we can do, that don't even write in database, you just write in cache. You just write in cache and then you return, because writing in the cache is faster. So now the problem, good thing is it's a faster write, even faster write, but eventually you have to sync that back to the database, right? So when you have to sync that back, you need to have again some way to uh, do that syncing somehow from cache to database.
So one more question. So when they talk about the cache, right, let's say the S1 server is in US, East US, and S2 is in the West US, and S3 in the Hong Kong, right? So I assume this, the caching should also be distributed, correct? A different location, their instance.
Yes.
So how are we talking in the context that that updating the cache at different location will be handled by Redis cache, or this is like scope of this discussion?
So when you will get the Redis cache or something, they have an option to have cluster, cluster options. So they can be also geolocated.
Correct. So they will update themselves. Right? So you're not. We assume that okay, that's the design of the technology, that whenever we update the cache.
That's why I deferred this to let's not talk about how it could be implemented.
Correct.
But we are just using something built in.
Got it. Okay.
Okay. Wow. So that is another design choice. It has some problems. What if we wrote into the cache, but now we lost the data, right? Does Redis guarantee that your data will not be lost? I have to check that, but you have to think about all those things before making that choice, or at least write it somewhere where you can actually finally you can make your data consistent in the database.
Redis actually offers persistence to some extent. You can actually keep it to every write, or every 5 minutes or something. You can save it to the. You can write it to disk.
Yes, that was my idea. It's a good implementation. You can put it so you will have a snapshot of things, right? So you will have a snapshot, and after some time you can continue to evict from the behind, so that you don't grow it very large. So that should be okay. That is one way to solve that.
Could you repeat that idea?
Which idea? Which we just talked about?
Yeah.
So what he's suggesting, that whatever we are doing, write it somewhere, right? Write it somewhere, and when things go wrong, you have something already. Like in database, we have a write ahead log, right? Whatever database does, it writes first. Actually, we will talk about that very soon, hopefully in the replication or sorting, if we have time.
Do you mean using a persistent data store?
Now, the thing is, it's a very tough choice, because I used cache to make it faster, right? Make things faster. And if I have to make a choice to actually make things slower in terms of it's a tough choice. You understand what I'm saying?
Mm-hmm.
So we'll have to think about it. And I think Redis may have a way to, because it uses cluster, right? So even if something fails on one node, they will have this stored at other nodes. So it will not be fully full failure. But yeah, I would defer that to look at the Redis documentation. Right? Because anything distributed, it has to have something like, some backup or something like, multiple nodes having the same value. That is the whole point of redundancy. So we'll look into it, maybe go through this and check this thing. Are we okay? Should we move ahead? I hope so.
Yes.
So it's already 2 hours, 15 minute session so far. And what I was trying to talk about is sharding, replication, some consensus algorithm, and little bit about gossip protocol, and then little bit rate limiting, capacity estimates, and then some probabilistic data structure.
That might be another session.
So what do you think? Should we just stop for today?
Yeah, next session would be fine. Like we can do this, and we can come back to some question if something is there. The next session in the start, and then you can move ahead telling other things.
Roger, we do want you to come back. We don't want you to be like, make you so exhausted.
Yeah, actually it's on record, so I will talk the real truth after the recording. So in that case, let's stop here and we will talk about other things which we just talked about, like, in next session maybe.
Yeah.
Sure. Yeah.
Thanks a lot, Roger.
Yeah, thank you.
Yeah.
Yeah, thanks, Roger.
Thank you very much. Like,
Thanks.
it was a
Thank
great
you, Roger.
participation today. Yeah. Let me stop the recording.